Hello friends, welcome to engineering tutorial. Now, in the previous video we discussed about the concept of min terms or product terms, and then we discussed about the canonical Boolean expression formation using sum of products method. So in this video we are going to discuss about the other method of representation of the canonical Boolean expression or standard Boolean expression, which is product of sum or product of max terms. So before we discuss product of sums, first let us discuss max terms in detail. Okay, so max terms. Suppose we have again we'll take three Boolean variables a, b, c. Okay, we have three Boolean variables available to us and we have to form Boolean terms using these three variables. Suppose I form Boolean terms as this. A plus b plus c, a bar plus b bar plus c, a plus b bar plus c, then let's say a bar plus b bar plus c bar, and so on. I will form variables like this. Now here you can see that the variables, the individual variables that are involved, they are added together to form a term. So in max terms, a term is formed by one or more variables, Boolean variables, being ORed or summed together. Okay. Now, in each of the following max terms, you can see that all the variables are present. It includes all the variables available to us, a, b, c. Nothing is missing. No variable is missing from each of the following terms. So we can say that these max terms or sum terms are in standard form because no variable is missing. It includes all of the three variables. All of the three variables are involved. Either it is in uncomplemented form or complemented form, but it is present. So this is how max terms are formed. Okay. Now, another important concept associated with max terms or sum terms is the logic value associated with the complemented and uncomplemented variables. Okay. In max terms, the complemented variables, okay, the complemented variables, let's say we have a variable a and it is complemented, a bar or a complement. Any complemented variable, it represents logic 1 or the high state. And the uncomplemented variables, they represent logic 0 or the low state. Okay, Now this is opposite to that in the min terms. In the min terms it was the opposite. In case of min terms it was the opposite. Complemented variables represented logic 0 and uncomplemented variables, they represented logic 1. So it is opposite to that of min terms. Okay, so this is how the variables complemented and uncomplemented, they represent the respective logic levels. In case of both max terms and min terms, it is the opposite convention. Okay, another important thing. Now the max terms, okay, the max terms, they are represented by the symbol capital M subscript J. Okay, the max terms, they are represented by the symbol capital M subscript J. Now if you remember, if you watch the min term video, the min terms are represented by the symbol small m subscript I. Okay, so the min terms are represented by the symbol small m subscript I, whereas the max terms are represented by the symbol capital M subscript J. Okay, so let us see how the max terms represent the given binary numbers and the respective decimal numbers, like we did in the min term case. Okay, now we have to remember here that in max terms, complemented variables represent logic 1 and uncomplemented variables represent logic 0. Okay, let us say we are using three variables again, A, B and C. So first A plus B plus C. So here this represents 0, 0, 0. Uncomplemented variables represent logic 0 in max terms. So it is 0, 0, 0 in case that is A, B and C. Okay, so this is equivalent to binary this representation, and in decimal it is 0. Okay, next A plus B plus C complement. Here each uncomplemented variables represent 0, so A and B are uncomplemented, so they are 0. Now C is complemented, C bar, so this will represent logic 1, so it is 0, 0, 1, the binary equivalent, and in decimal it is 1. Okay, next we have A plus B complement plus C. So here 0, 1, 0. Uncomplemented terms A, C, 0, 0. Complemented term B, complemented variable B is 1. Okay, so it is 0, 1, 0 in binary, and it is decimal is 2. Okay, next is A plus B complement plus C complement. This is 0, 1, 1. Okay, only uncomplemented variable A, it is 0, B and C are complemented, so they represent 1 and 1. So it is 0, 1, 1 in binary, and in decimal it is 3. Similarly, if we proceed, last one will be a complement plus b complement plus c complement. This will represent 1 1 1, logic 1, logic 1, logic 1, as all the variables are complemented. This binary representation will be 1 1 1 and it will be 7 in decimal form. Okay, so this is how the max terms are formed. Now the symbol, okay, the symbol, the max term symbol here of the respective, this entire thing a plus b plus c, it can be represented as capital M subscript 0, which represents decimal 0. Similarly, a plus b plus c bar, it can be represented as capital M subscript 1, means it is the max term for decimal 1 or the number 1. Then a plus b bar plus c, which is the max term equivalent of 2, it can be represented by capital M subscript 2. Now the symbol for max term is capital M subscript j, if you remember. So these are the respective symbols, the max term symbols. So a plus b bar plus c bar, which is the max term equivalent for decimal 3, it can be represented as M3, capital M subscript 3. At last, a bar plus b bar plus c bar, which is the max term equivalent representation for decimal 7, it can be represented as capital M subscript 7. Okay, so this is how the max terms they operate. Okay, now we will discuss about product of sum using the max terms